Hello everyone, in this video I'll be explaining you the problem subtract or divide. So it was asked in starter 199 of Codechef. So yeah, let's try to read out the problem. So you are given a positive integer n. In one operation you can do either of the following two actions. If n is greater than 2, choose to change n to n minus 2. If n is greater than 1 and n is even, choose to change n to n by 2. So okay, so got it. So two operations we'll have to do. Find the number of different positive integers you can form if you are allowed to perform as many operations as you want, starting with n. Okay, so note that you are allowed to perform different types of actions in different operations. So yeah, this is an interesting problem, so don't worry, I'll be telling you. So first let's try to take the input. So we have t as number of test cases, and for every test case we'll call a function solve, and in each test case we have n as integer, yes, small n. So yeah, let us take some of the examples and understand. So n they have given is 1 in first case. In first case n they have given is 1, so they have given two operations. First operation, what they're saying is n is strictly greater than this 2, so in that case you can make n as n minus 2. In second operation, what they're saying is n is strictly greater than 1 and n modulo 2 equals to 0, which means this is even. If n is even number, then you can make n as n by 2. So if you try to think, they have given first example. So if you try to put in these two operations, you can't make it, because 1 greater than 2 is false, 1 greater than 1 is false, 1 equal to 1 is true, but this is not there. So these two are not satisfied, so you can make only one n as one of the unique. If you try to put in a set, so you have one number, one unique number, one unique positive number. So in this case your answer is 1. So yeah, our answer is 1, so don't worry. I'll be explaining the second one. First example is just to understand. I think I'll be taking 2-3 examples, so then you will understand. So when n is 2, now if you try to put in this operation, you can't do it, because 2 greater than 2 is false, so you will have to put in this only. So in first one, can you put it? Yeah, because n 2 is greater than 1 and 2 is even number, so you can make this as 2 by 2, which is 1. So when you have reached 1, so there is no operation that you can do. So in this case, if we try to see, you have two different numbers, so two different positive numbers, so you'll have to return to display 2 as the number of positive integers that you can make from 2 using the above two operations. So let's try to understand when n is 4. When n is 4, so this problem I'll be doing constant time. So yeah, first let's try to understand how do we approach this problem. So when n is 4, it is coming in this operation, so it will be n minus 2. When n is greater than 1 and n is even, so we can make 2 by 2, which is 1. So we have got this. So when it was 4, we could have put in this also, so let us put in this as well. So in this, if we try to put it, 4 is greater than 1 is true and 4 is even number, so you can do 4 by 2, which is 2, which is as same only. So when we are at 2, so you can't do this operation, we are doing this. So how many different numbers in this you have got? So you have got 1, 2, 4, so 3 different numbers you have got. So for this our answer is 3. So yeah, for this, for n is equal to 4, our answer is 3. Let's try to understand 6. When n is equal to 6, so whenever n is greater than 2, try to put first operation, so you will get 2, 4 you will get 2. Now you put operation 1, so you are getting 1. So and at this point you can also do this operation, second operation, because 6 is greater than 1 and 6 is even number, so 6 by 2, which is getting you're getting as 3. So I think you guys are getting. So when you have 3, so again you can apply one first operation, so you'll get 1. So you're getting how many different numbers? 1, 2, 3, 4 and 6. So one hint I'll give you, when n is even number, so you will be getting that n by 2 elements. All the n by 2 elements will be there, like 6 by 2 into case if you see, that is 3. So all 3 elements will be there from 1 to n by 2. All the elements will be there. So if you try to check it, you have 1, you have 2, you have 3. So just if n modulo 2 equals to 0, is it looking? Yeah. So in that case you are getting n by 2 elements. This is first observation, like you have 1, 2, 3, but still you have 2 and 4. This I'll try to derive, don't worry. When n is on odd, that is very easy case. So now 6 we have dealt it. Now let's try to deal with n is equal to 8. So when you have n is equal to 8, try to use this operation. You'll make it 6, you'll make it 4, you'll make it 2, and try to use now this operation, you'll make it 1. So from 8 now you can make this operation as well, because 8 is a even number and it is greater than 1, so you'll be making 4, which is here already there, so it is fine. When it is already there, you don't have to do anything. When n is 6, so now again you can do this operation. 6 is greater than 1 and 6 is even number, so 6 by 2, that is 3. Okay, so when you have 3, so again you can use this operation, or this one you can't use because this is odd number and should be even number, only then you can use this operation. But this is you can use first operation and you can make it 1, which is already there. So as I said, when n is even number, so all the numbers from 1 to n by 2 will be there. So can you check it? So 1, 2, 3, 4 we have, as 8 by 2 is 4, and we have still 2 elements, therefore that we'll try to derive formula. So okay, so when n is equal to 9, let's say, and this is odd number, so it is very interesting one. When it is odd number and it is very easy, so you can't apply this operation. Why you can't apply this operation? Because 9 is greater than 1 is fine, but it should be even number, but it is odd, you can't apply this operation. Now you'll have to apply this operation only, because 9 is greater than 2, so you'll be subtracting minus 2, which is 7. So when you're subtracting minus 2, when you're subtracting 2 from the odd number, you will get again odd number only, and again you can't apply this. So apply this operation, you will getting 5. Apply again first operation, apply again first operation. So in this case you will not be getting any even number, so you will be getting all the numbers from n to 1, all the odd numbers from 1 to n, all odd. Okay, so how do you find how many numbers are such different numbers are there? So it's easy way. You just do n plus 1 by 2, because 1 to n there are 5 numbers, 1, 2, 3, 4, 5. Now if you try to put it here, it is 9 plus 1, which is 10, 10 by 2, which is giving you 5. So now one thing you have got, if n modulo 2 equals to 1, which it is an odd number, your answer will be n plus 1 by 2. And let's try to deal with the even case. When n is 10, let's say we are seeing, so when n is 10, so you use first operation only. You'll be making it as 8, you'll be making it as 6, 4, 2, and then first operation you'll use it will be 1. Is it looking? Yes. So now since this is greater than 2 and greater than 1 and it is even, you can make half of this number, which is 5. And when it is 5, now again since it is 5, you can apply all the first operation. 3, which is 1, 1 is also there, don't worry. So and from here also you can make as 2, 8 by 4 it as 2, and 6 by 2, which is 3, it is here only, so no need to take care of that. And if you try to put again any other thing, so n by 2, what you are saying, it is like 1 to n by 2, which is 1 to 5, 1, 2, 3, 4, 5 we have, but if you try to see this 3 extra thing, one more we have. And how do you calculate how many numbers are there, such numbers? Because when you are dividing even number, when it is odd number you have that formula, but when you have even number, so in that case you will be basically subtracting -2, or you will be dividing by 2. When you are dividing it by 2 and you are getting odd number, so whichever let's say you have 12 n is 12, so when you divide it by 2 you will getting 6, okay, and this is even number. But uh, okay, after subtracting you will be getting again 10. So what I'm trying to say is that whichever number I mean greater number you have as even number, and dividing it by 2 you are getting odd number. So from that number all the odd numbers will be there till 1, and all the evens number will be there till n sorry, till 1. So remaining number whatever we have, that we will have to find. So in this case, as you can see, 7 you can't have it, because 10 is the maximum number, and if you divide it by 2 you are getting 5, you will not be getting 7. And if you are using first operation, so even number -2 will give even number only, it will not give odd number. So 9 and 7 you can't derive from this, okay. So how do you calculate now this? So it can be done, see 3 numbers are there, so you take n, which is 10, minus half of that you do, n by 2 you do, so it is like 10 minus 5, it is 5. But you don't have 5 numbers, you have 3 number, take still half of that. But you'll have to be cautious, if you take just 2 it will be 2, but you have 3 numbers, right? So whenever it is odd or even sorry, when it is even, in that case it is good, but when it is odd you will have to deal with n plus 1 by 2. So basically it's like you are getting 5 plus 1 you do 6 divided by, which gives you 3, so you have 3 numbers. So this formula again, how you are doing, it is like n minus n by 2 plus 1 you are doing, right, and dividing it by again 2. So 6 by 2, which is 3. So this is the formula that you will be using. Let's try to put it for let's say 12, sorry I rubbed it, you have n, okay. So where n is 12, it is even number, so first you'll be getting is like 12 by 2 is 6, so 1 till 6 all numbers will be there, and this can be found using n by 2, which is 12 by 2 is 6. So 6 numbers are there, 6 different unique numbers are there. Now from this is 10, this is 8, this is 6, so whatever number are there, right, these 3 numbers are there. So how do you find this 3 number? So again you will be putting this formula, so it will be 12 minus 12 by 2 is 6 plus 1 by 2, so 5, okay, so it is 7 by 2 is 3, so you're getting 1 2 3 numbers. So I think you guys are getting how to do it. So just we need to, for n is, when n is even, your formula will be again whole divided by 2. When n is odd, your formula is this. So yeah, in this way we can do in constant time, both space and time complexity is constant. So you'll have to check, first take integer answer as one of the variable. Now you'll have to check n and 1, which means it is odd number. I think in bit manipulation you guys know the last bit in odd number will be set. So when you're doing AND operation with that, so AND operation is like whenever both the zeros are there, so it is 0. Whenever both the ones are there, it is 1, or else even if it is 0 1 or 1 0, it is 0 only. So when last bit is set and I'm ANDing with 1, so it is odd number. So in case of odd number, we came to know that like it is n plus 1 by 2, and in case of even number, it is n by 2 plus n minus n by 2 plus 1 divided by 2, and at the end you will have to output the answer. Let's try to run it, and we are expecting 1 2 3 5 1 2 3 5 6 5 75 6 5 75. Let's try to submit. Yeah, it got accepted. So basically this was observation based and deriving the formula problem. So yeah, thank you guys for watching the video.